let us start with another prerequisite right now. I spoke about the first prerequisite, which is the fact that a matrix multiplication on a vector leads it to a convergence state. And now I'm talking about the second prerequisite, which is actually a very straightforward observation. It is about addition of two vectors. We have studied the notion of scalars and vectors in our high school days. I'm just going to revise that and make some subtle observation about them. Okay, what happens when you add two vectors? It's a very straightforward question. We all have added a comma b, vector a comma b added with c comma d gives you a plus c and b plus d, correct? But we haven't observed something very important here. Let's observe that now. So here is my question. What is the sum of 2 points in 2 dimension? Let's say this is my 2-dimension plane and this is my first point. I'll give it some name. Let's say the point 30, 70, right? And another point sort of relatively close to origin. And this point is 5, 3. All right. So let me join the corresponding vector. What do you mean by that? You just join the origin and the point by a line. This is called a position vector. As you saw, I did that for both. Okay, this one as well as this one. Next, what is the sum of these two vectors? What can you say about the sum of these two vectors? This is the right time for you to pause the video and compute the sum and take a look at where exactly the sum comes. What is the sum? 30 plus 5, 70 plus 3, 35, 73. Where exactly is this point? What is its direction? By direction, I mean when you join the origin and this point, is it close to the point 30, 70 or is it close to the point 5, 3 is our question in hand. Let's see that in detail now. So let me write that once again. And my question is, what is the sum of these two vectors, right? And I will try to find the sum. Very obviously, the sum is simply this point. That's the sum of 30, 70 and 5, 3, right? I didn't mean to exaggerate this concept. It's a very straightforward concept, but the observation is not so straightforward. The observation comes next. This 35, 73 is close to 30, 70 than 5, 3. This vector, as you can see, 5, 3, the resultant vector is somewhere 35, 73 is somewhere close to this vector than to this vector. Did you observe that? Yeah, and I'm sure you know the reason as well. Okay, we observed this. Next, so let's see what exactly this means. The resultant point is close. When you add, the resultant point is close to the big vector. What do I mean by big vector? The vector that is big in amplitude. This is the big vector I'm talking about. The resultant point, which is this, is close to the big vector because the vector we added was a small vector. Now please note, if two vectors which are of the same amplitude, when you add, this may not happen. This will happen only when you take a big vector and add it with a small vector. What do you mean by a big vector? A vector with a big amplitude is called a big vector. And this is a small vector because the amplitude is small. Right? Okay. So this is a small vector, right? Okay. What is the moral that we learned just now? What did we observe just now? So you can pause and think about what we just now said and then continue the video. When we add a big vector to a small vector, the resultant vector is close to the direction of the big vector, big in quotes, right? Perfect. Although pretty obvious, you will even be wondering, why did I even have a lecture on this? Such a simple concept. This plays a key role in understanding the convergence of the matrix that we discussed previously. Alright, so it is important for us to spend some time on this seemingly trivial concepts. Most of the concepts are actually trivial, but their significance is very high. So it's important for us to understand, although appearingly trivial, it's important for us to understand these concepts one level deep, because they will come in not so obvious places and we may not be able to interpret them properly. So big and small, by big and small I mean in the amplitude, as I told you people, right? Okay, perfect. So this is the distance from the origin. I'm just revising whatever I said. So the moral is very clear to you people. When you add a big vector to a small vector, you get a vector close to the big vector, both in direction as well as amplitude. Okay. So big plus small is equal to something close to big, both in direction as well as amplitude. So this was our prerequisite 2. And it will help if we can recollect prerequisite 1. Can you all recollect what is prerequisite 1? Prerequisite 1 was this. Prereq 1 was simply the fact that when you multiply a matrix to a vector repeatedly, it converges. So please ensure that you don't go further without understanding this prerequisite 1 and